Alright guys, today we're going to look at solving logarithmic equations. So type 1 is going to be a log equals a log. Okay, so we're going to condense. Remember the properties that we looked at before. We had the product property, the quotient property, and the power property of logs. So remember how to use those. And then use the one-to-one property. So that means if we have one logarithm equals one logarithm, that means our equations are in condensed form, then you can drop the logarithm similar to what we did back with exponentials. When they had the same base, we dropped the base and set the exponents equal. Well, with these, we're going to drop the log and solve from there. All right, so then you solve and you check for extraneous solutions. Okay, extraneous solutions is something we talked about back with rational and radical equations, and they sometimes show up with logarithmic equations as well. So before we get started, I would take a minute, and in your notes section, there is a link that takes you to this where it talks about extraneous solutions and it talks about what they are and where they come from, and it's just kind of good to review that. Okay, so just a quick reference. An extraneous solution is a solution derived from the original equation that when you plug it in to check it, it doesn't work. Okay, and here it kind of shows you some examples of why extraneous solutions show up. So we know that 2 does not equal negative 2. But if you do the same thing to both sides, then you square both sides, and now 2 squared equals 4, and negative 2 squared also equals 4. So even though you take a false statement and you do an operation to it and it becomes true, then this can produce extraneous solutions. So I would take a minute and look through this. It's going to talk about extraneous solutions. It's going to show you some examples, and it goes down through, and it even shows you examples here of the 2 solutions they got for this question. They got negative 4 and 3, but when they plugged it in, negative 4 was an extraneous solution. So it's not actually a solution. So just kind of review extraneous solutions before you get started. All right, now, since we have talked about what that means, let's go ahead and look at number 1. So number 1, it has a log equals to a log. So we can drop the logs and just say 5x plus 9 equals 6x. All right, subtract 5x from both sides. And you do have to remember how to solve all different types of equations. This one's a very simple one-step equation, so it's no big deal. All right, plug it back in and check it. So 5 times 9, if I plug 9 in for my x, 5 times 9 is 45, plus 9 is 54. If I take 9 and plug it in over here, 6 times 9 is 54, so this one works. All right, over here, we have a log equals a log again. So we're going to have 1 minus 4n is equal to 2n plus 43. All right, to solve this, I've got a variable on both sides, so I need to get my variable on one side. So I'm going to add 4n to both sides. So I'm going to have 1 equals 2 plus 4 is 6n plus 43. All right, now I'm going to subtract 43, and 6n equals negative 42. Divide both sides by 6, and n equals negative 7. All right, so take the negative 7 and again plug it in for n and see if it works. All right, so if I take negative 7 and plug it in, I've got negative 4 times negative 7 is positive 28, and then 1 plus 28 is 29. So it would be 29 on this side, and what happens when we plug it in over here? So 2 times negative 7 is negative 14. negative 14 plus 43, so that's 43 minus 14, which is 29. So again, when I plug it in and check it, this one works. All right, number 3 is a log equals a log, just like the first two. So we're going to skip it because all you have to do is drop the log and solve. Number 4 has 2 logs on the left, which means we have to use our properties of logarithms from the last section. So we have a log plus a log, and if you remember our properties, when you add, you can condense those by changing that to multiplication. So if I change that to multiplication, I'm going to have log of 4 times y plus 5. And commutative property says the order doesn't matter since that was one term. That's why I put it in the front. If you write y plus 5 and put 4 on the other side, that's the same thing. So again, I just use commutative property to put the 4 in the front. But addition, remember, changes to multiplication here. All right, then I have 1 log equals 1 log. So now I'm going to have 4 times y plus 5 equals 72. And then I can solve from there. So parentheses means I distribute. So 4y plus 20 equals 72. Subtract 20. 4y equals 52. Divide both sides by 4. And y equals 13. All right, usually when you have one answer, it's going to be a good solution. A lot of times when you get an extraneous solution, it comes from when you have 2. That's just kind of a hint. You still need to check these. Make sure you plug it back in. If you want to use this equation where you condensed and have one single log on both sides, it might be a little easier. So 13 plus 5 is 18. 18 times 4. Let me check. 18 times 4 equals 72. So when you plug this in and check it, this one does work again. All right, guys, moving on to number 5. As always, I'm moving through these kind of quickly. If you need to pause the video until you write something down and then start it again or even back it up a little, make sure you do that so that you have good notes that you can read and look back through when you're trying to do your assignments. All right, so number 5. This one is also going to have to use a property because it's got 3 multiplied in front of here. So before we drop the log, we need to move this to a power. Remember, this is the power property, and it means it becomes an exponent. So we're going to have log base 7 of 4 to the 3rd power equals log base 7 of 4a minus 8. And then we can drop our base. So then we have 4 to the 3rd, and 4 to the 3rd power is 64. And that equals 4a minus 8. I'm going to add 8. And 4a equals 72. Divide both sides by 4. And a equals 18. All right, and again, you want to plug that back in and see if it works. The number on the left is just a number. That's going to be 64. Does that equal 4 times 18 minus 8? So check that and make sure it works. All right, number 6 also uses properties of logs. Remember, when you have subtraction, that means division. Okay, so we're going to have log base 4 of 68 divided by 4 equals log base 4 of 3n plus 11. All right, and then we can drop our log because now we have a single log on both sides. And then 68 divided by 4 is 17, and that equals 3n plus subtract 11. And again, once you get rid of the logs, it's just a simple equation that you've solved for years. So all we're doing is solving equations. That's why I'm moving through these kind of quickly. Logarithms are new, but solving equations should not be new. All right, so number 6, we got 2. If we plug back in 2, 3 times 2 is 6. 6 plus 11 is 17. 17 equals 68 divided by 4. Again, when we plug that in, it works. All right, for number 7, we have 1/2 times log base 6 of 25, and we know that 1/2 becomes the power. And if we have 20, we have log base 6 of 25 to the 1/2 power. Remember that, now we can drop the bases. 25 to the 1/2 power. If you remember when we worked with radicals or square roots, anything to the 1/2 power is the same as a square root of that. Okay, so that's from a previous lesson as well. So 25 to the 1/2 power is the same as square root of 25. Square root of 25 is 5. And that equals 23 minus 4w. All right, now subtract 23 from both sides. Trying to get the variable by itself anytime you're solving an equation. So I'm going to do 23, let's see. Negative 23 plus 5 is going to be negative, 18. And that's going to equal negative 4w. And divide both sides by 4. Okay, 2 negatives is a positive. 4 goes into 16 4 times with 2/4 left over. 2/4 is 1/2. So this will be 4.5 or 4.5 equals W. Excuse me. All right, now plug that back in and check it. So we know the left side, 25 to the 1/2 power. This side is going to be 5. Let's see what this is if we put in 4.5 on this side. So negative 4 times 4.5 is negative 18, and 23 minus 18 is 5. So same thing as 25 to the 1/2 power. So that one does work. All right, let's see if we can get one more in before the video ends. All right, so here we have log base 3. Over here we have 2 logs. So this time we're going to have to condense on the right side. So to condense on the right side, let's move the 2 to a power. And then the negative means we have to divide. So I'm going to go ahead and put 2p minus 5 equals, and we're going to have 6 squared over 4. And I went ahead and dropped the logs because once we condense this to a single item, then we're going to drop the logs anyway. So just to save time, I went ahead and did that. So I'm going to have 2p minus 5 equals, and this is going to be 36 divided by 4. And then 36 divided by 4 equals 9. And then we have 2p minus 5. Add 5. 2p equals 9 minus 5 is 4, and divide both sides by 2. So p equals 2. And again, we need to check this answer. So 2 times 2 is 4. And 4 minus 5 is negative 1. So it's going to be a negative 1 right here. And then 6 squared, we've got 36 divided by 4 is 9. And it does not look like this works when you plug it back in. So this looks like, if I did this correctly, this would be an extraneous solution. So it would not be a solution. All right, have a good day.